Hello, it's time for Unit 2, Lesson 15, where we're going to continue our use of polynomial division, but this time we're going to have remainders. So, one thing that they do is they start us off with a notice and a wonder, and we notice with long division and numbers that there are times when numbers divide unevenly. So 330 divided by 10 is an even answer of 33 with no remainder. And there are times when we have a remainder. So 330 divided by 4 would give us an answer of 82. And if we saw it on a calculator, it would say 82.5. What that really means, how they get that from something like long division here, is that it's 82 plus the remainder of 2 as part of our original divisor. It's like 2 out of 4. So this is what we're going to start seeing, that not all of our factors are going to divide in evenly. We're going to see that sometimes things don't divide evenly and we have some leftovers. Okay, and then we also have this idea of the remainder theorem. So our remainder theorem, let's go ahead and define what it is we're looking at. The remainder theorem tells us that if we have no remainder, then we have found a factor. And of course, we know that if we found a factor, that means we have also found a zero. Also, an x-intercept is what I'm going to start calling that x-intercept of the graph. And on the flip side, if we have a remainder, then we haven't found a factor. It is not a factor, and it's not an x-intercept. So this is our big thing that we're going to think of. We're making the connection back again with remainders dividing evenly, and whether something is a factor or an x-intercept or not. I'm going to skip past 15.2. It's an interesting idea that we could figure out what that is if we only knew one factor, but we're going to move past that, okay? So we are going to do the "Are you ready for more?" So if you look with me on that page, they have done some division for us. And we're taking this polynomial, it's a third degree polynomial, and we're dividing it first by x plus 3. So I'm not going to look at any of this stuff yet. I'm only going to look at this x plus 3. And they've actually done the grid division for us. So I'm just going to go through and check that they did it right and add some other details to it, because we're going to actually see how a remainder shows up in our grid division. Okay. So they set it up just like we have done before. They take the divisor, x plus 3, and they put it on the outside of a grid. They take our first number and they set it up on the inside of the grid. Here's our normal division in the grid setup. And they start calculating some values. So they know 2x squared. Once you know the top value, we of course know the whole column. I am going to definitely be putting in these diagonals. You might find this very helpful when we get to this part here. We know that those two diagonals would have to add up to 5x squared. So if we're at 6x squared, we need to get to 5x squared. That means I need to take 1x squared away. So that's how they got this. And then they're like, well, x times something to get to a negative x squared has to be a negative x. When you know the top of a column, you know the whole column, we can fill it all in. Again, on our diagonals, we need it to equal positive x. If we're at negative 3 and we need to get to positive 1, we have to add 4 x's to make that happen. Now that we have that 4x, we know it multiplies by 4. And then we multiply them together and get to 12. But it was supposed to equal 10, not 12. So we have to follow the math. These two would multiply to 12. And so here's where that remainder thing is going to happen. 12 plus something have to equal that positive 10 that's here in our standard form. Now I've fallen out of the grid. I have a constant in my last column, so I can't go any farther. I can't break it down anymore. So this is now falling outside the grid. If I am at 12 and I need to get to 10, I need to subtract 2. That is the remainder. And this is what a remainder looks like when we do polynomial division with remainders using the box method. So the way that we're going to start writing these answers, or how we're going to start calling or labeling these things, we're used to this idea that this is our result of division, right? That's our answer, our solution, our quotient. There's lots of different ways to describe that, but I'm going to mostly call it a result. So just like, I'm going to flip back over to this warm-up that they had for us, just like whatever showed up on the top of this division is that whole number out front. It's the result of our division plus the remainder over the divisor. Remainder over the divisor. We're going to do the same thing here. The result plus the remainder there over our original divisor. You can pull it from either place. So that's how we're writing it. We're writing it as the result of division plus the remainder over the divisor. That original thing that we were dividing by right here. And we can, of course, flip-flop these. We could have the fractional part first. That doesn't matter which one. But this is what we're going to start working towards, is using the box method only from the top left to the bottom right until we find a remainder. Now our second example here has the same polynomial up top, but it is dividing by x squared minus x. So again, they put that one that we're dividing by over here. We're still using 2x to the third. They find 2x, they multiply. The diagonals have to add up to 5x squared. So they have to add 7x squareds. We already have x squared, so we need to multiply by 7 to get here, and that means when we multiply 7 times negative x, we get a negative 7x. So I have a constant. This means I'm at the end of my grid. I have a constant at the top here. So I'm at the end of my grid. Everything else is going to be falling outside as a remainder. Now I've used that 5x squared, but I haven't used this plus x. So I need to get to a positive 1x. I'm at negative 7. I need to get to positive 1. That means I need to add 8 x's. But I also need this positive 10, and there is no more columns for me to work with to get there. So that is also part of my remainder. So with polynomial division with a remainder, this is what we have and what it looks like. The result, 2x plus 7 plus the remainder, 8x plus 10, over the original divisor, x squared minus x. So we're going to start seeing with the second half of our unit, as we move into fractions and interesting graphs like this, we're going to start seeing that things aren't always going to divide evenly, but we can still keep on working with them and find parts that do divide evenly and remainders are there. I'm going to keep 15.3 into a separate video, so if you need to keep on watching, please find that next video and see how that looks.